The goal for today is to write formulas for arithmetic and geometric sequences. For arithmetic sequences, we're going to write formulas that have the letter A in them, and the A is going to stand for arithmetic. In the geometric sequences, we're going to use the variable G for geometric. And there's some basic information that we'll need in order to write those formulas. So for arithmetic sequences, they change by addition. In this case, we are adding negative 1.5 each time, which is the same as saying subtracting 1.5 each time. So our common difference is negative 1.5. To write the formula for this sequence, we will need to know this D value, but we'll also need to know the first term of the sequence, which in this case is 6.5. So we're going to be referring to this first term as A sub 1, and that just means the first term in an arithmetic sequence. Now that we have these two pieces of information, we're ready to write our recursive and explicit formulas. The recursive formula is the kind of formula you use if you know the term that came before the one you're looking for. So in this case, if we were looking for term 7, we'd use the recursive formula if we already knew term 6. We use the explicit formula if we do not know the term that came before. For example, if we only knew the first 3 terms and we were looking for the 100th term, we wouldn't want to have to calculate the 99 that came before. We would want to jump straight to the 100th term using the explicit formula. But let's start with writing the recursive formula. So this is the general formula. And we just need to fill in the information that we know, which in this case, we know the D. So we're going to write A sub n equals A sub n minus 1, which is the term that came before, plus D. So here's how that would look. A sub n equals A sub n minus 1 and then remember what your D is. Your D in this case is negative 1.5. So you can either write negative 1.5 or you can write it as adding a negative. So the same beginning of your formula, A sub n equals A sub n minus 1 plus negative 1.5. Both of these formulas are equally correct. Some people like to write it this way. Some people like to write it this way. They mean exactly the same thing. Now let's write our explicit formula. For this one, we'll need to know our first term and our D. A sub n, the term we're looking for, equals our first term of the sequence, which in this case is 6.5, plus our d, which you'll recall is negative 1.5, times n minus 1. And that is one way to write this formula. Because you have a negative d, you can also write it the other way. Instead of saying plus a negative, just to say minus. So a sub n equals 6.5 minus 1.5 times n minus 1. Be careful. Don't be tempted to combine these terms together and do 6.5 minus 1.5 and simplify them to 5. That's not allowed because order of operations says we have to multiply that negative 1.5 times the n minus 1 before we combine like terms with that 6.5. So the way it's written now is correct without any simplifying. Now let's look at writing geometric sequences formulas. These were arithmetic. To write, here's the geometric sequence that we're going to look at first. So we know that our common ratio is 1/10. We're multiplying by 1/10 each time to get from term to term. Multiplying by 1/10 is the same mathematically as dividing by 10, but the r uses the multiply value. So our r is 1/10. We also will need to know the first term of our sequence, which in this case is 1234. And then, okay, so we have the two pieces of information we need. We have the first term of our geometric sequence, and we have our common ratio, or our r value. And the reason we're using a G instead of an A is because it's a geometric sequence. G for geometric. So now here are the general formulas for geometric sequences. We have our general recursive formula and our general explicit formula. So we're just plugging in the values. We're plugging in our r value in the recursive formula, and remember our r is 1/10. So our recursive formula for this sequence is g sub n equals g sub n minus 1 times r. So here is our recursive formula. To get the term, take the previous term times 1/10. Now, to write our explicit formula, we're going to need our first term, and we're going to use our r again. So g sub n equals g sub 1, which is our first term, which is 1234, times r, raised to the n minus 1 power. I put the 1/10 in parentheses because the whole fraction gets raised to the n minus 1 power, not just the numerator, but the 1 and the 10 both get raised to the n minus 1 power. The parentheses help with that. So now you know how to write recursive and explicit formulas for both kinds of sequences, arithmetic and geometric. I hope this helps. Have fun!